Hello everyone, welcome to my new programming club. Today we will be solving another daily lead code challenge. And the challenge name is search in a rotated sorted array. So you are given an integer array nums which is sorted in ascending order and the values in that array are distinct. So prior to being passed to the function, what the what has happened to the array is that it is being possibly rotated at a unknown pivot index, and pivot index is from 1 to nums dot length. So it will be not the zeroth index, and so other than the zeroth index it can be any index which at which it's rotated, and the resulting array looks like this. For example, if this might be the rotate if we rotate this array at pivot index 3, then this array will be achieved. So let's take this example to understand what the problem statement is saying by what it means by rotating the array. This is the example that is being talked about in the problem statement, and let's mark the indices. Let me quickly zoom it further so that we will be able to mark indices in a clear way. Yeah, I think that's fine. Okay, 0, 1, 2, 3, 4, 5, 6. Now if we decide to rotate at this index, let me quickly change the color. It's mentioning that we rotate the array at the index 3. So what we will, the resulting array, what you will basically do is you will take this part out and place it in the front of this part. 5, 6, 7, 0, 1, 2. It will the rotated array. Let me quickly check. Yeah, it's the case only. This is how the array is being rotated. Any index from first index, this index to this index, less than length of the array. Length of the array is here 7. Less than 7, 1 to 7, 1 to 7. So 1 to less than 7, which is 6, 1 to 6. So this will be the pivot of the rotated array. This will be the range from 1 to length minus 1. It is here. Let me quickly zoom in so that you will be able to see the problem statement in a clear way. Yeah. So the integer array is given to you, which is in sorted order. Prior to being passed to the function, it's possibly being rotated, and the index or the pivot at which it's rotated is in lies in this range 1 to length minus 1. So it's a example is given so that you will be able to understand how this rotation works. So what you are required to do is, given array nums, after possible rotation and an integer target, you you are given this rotated array. You will be given this possibly rotated array. It might be rotated or might not be rotated, but you will be given this array after performing zero rotation or no one rotation or no rotation, and you are given another number which is target. let's say it's x, and you have to tell whether this x number is target number is present in this array or not, and if it's present, you have to return the index at which it's present, index of target in this input array. So you have to return this. So, and if it's not present, you have to return -1 if not present. So till now, I hope the problem statement is clear to you. Uh, you must write an algorithm that runs in O of log and time complexity. So time complexity of the solution should, which you will be writing, should be O of log n. N is here nothing but the size of array, input array to your function. So you have to write such algorithm that runs in O of log and time. Now, since it's being mentioned that you have to write a particular time complexity algorithm, the input size does not matter here. Input size of the array, and you should know that the elements are in the range -10 is to power 4 to 10 is to power 4, and all the values in the array are distinct, and nums that is in ascending nums is an ascending array that is possibly rotated. It might be rotated or it might not be rotated. Uh, and the target also lies in the same range in which the elements are lying, -10 is to power 4 to 10 is to power 4. So how we will be approaching this stuff, this problem? Uh, since it's being mentioned that of log and searching is to be done, searching for the target should happen in of log and time. Searching for target should happen in of log and time. So which search algorithm runs in of log and time? It's binary search. Now question arises, what will be the thing in the array, or say question that you will be applying binary search on. Since we are required to return the index of the element, that is index of the element in the array if it's found, so we will be applying binary search over the basis of the array. Pardon me if some spelling is incorrect. I hope it does not affect your learning. Over the indices of the array, we will be applying binary search and checking for the if value at those indices is equal to target. If it's equal to target, then we will return the index. Otherwise, we will not. We will return -1. So those of you who are new to binary search, I will provide a link for binary search, link for article describing binary search, and you can check that link. Uh, out and read the article and then come back to this problem. I highly recommend you should have knowledge of binary search prior to solving this problem. So let's quickly dive into the approach. What we will do is we will search from the zeroth index to the final index, which is length minus one. Let's fix two pointers. One is left and another is right. Now, in a binary search, what we will do, this will comprise of our range in which we will be searching. This will be our search space. So this will comprise of our search space. These are nothing but the indices of the input. This is the input array. So you may ask that since the array might be rotated, for example, it which was in this case 0, 1, 2, and what was here 3, 4, 5, 6, 3, 4, 5. Let's take since the array is not sorted, whole array is not sorted. How to apply binary search? Since binary search only works for the sorted array, how to apply binary search? Now let's say now you have to understand that though the array is not sorted, but these two parts are sorted. The rotated part and the non-rotated part separately are sorted. Let's call this non-rotated part. Let's denote it by NR, and this is the rotated part. Let's denote it by R. So the NR part is also sorted in ascending order, and this R part is also sorted in ascending order. So both of them are sorted in ascending order. For any order, both of them are sorted individually. Individually. So both of them are sorted. So we can apply binary search separately on. We can apply binary search separately on them. If we know currently which part we are in binary search, we are in while applying we are in binary search, then we can carry on binary search part. Why we will be able to carry? Because both of the parts are individually sorted. So if we, let's say, if we know that we are at this part, rotated part, then we can apply binary search here. What I mean by we are at this part, if let's call this end as left, let's call this end as right. If and let me quickly clear the board out. Let's call this end as right. Left will be pointing to this initially and right will be pointing to this. So if you know that you are at the rotated part, this part, then you can easily apply binary search here. In binary search, middle element is taken from the range right to left. Let's call this mid position. If a element lies between, uh, if the value of the target lies between these two values, either it's lesser, it's greater than or equal to left, which is this, and let's call this mid position. This one mid position. So in that case, it will be nums of mid position target is lesser than nums of mid position. Now it might happen that you will straight away get the number at mid position equal to number at mid position equal to target. In that case, you won't have to check for anything. You will return mid position only because it's the index at which the target is present in the input array. Else, if it is the case, then what you will do is mid position is not equal to the target and left might be equal to the target or it might be lesser than that, then you will move to this side. So for moving to this side, what you will do is you will decrease the value of right and you will move it to mid position -1. Or else if it's not the case, uh, if the value is not lying between mid position and the left, let me quickly change the color. If the value is not lying in this part will be rejected and you will search in this part. So what you will do is else you will move your left to mid position +1. I hope you are able to understand. Now you may ask how we will be knowing that in which part we are in. Let me quickly clear the board out. Now how to determine which part we are in. What I mean by part is whether it's rotated part or the non-rotated part of the input. So when you will generate the middle index of this indices in the given range, let's call this mid position. Then you will compare this mid position number at this mid position with the number at right position, right index or right pointer say. The index to which right pointer is pointing. Then you will compare them and if this mid position Since all the values are unique, so it cannot be, these both cannot be equal. Uh, so if it happens to be greater than the right, for example, let's in the non-rotated part, in the rotated part, if you check for any value, let's check for 3, it's greater than this, right, the index to which, the number at the index to which right pointer is currently pointing. Now 4 is also greater than 2, 5 is also greater than 2. So all the values in this part is greater than the rightmost uh, element of your range. So if that's the case, you are in rotated part. And if that's not the case, you are in the non-rotated part. Let's denote it by another, this non-rotated part. Else you are in non-rotated part. So similarly, for this non-rotated part also, you will be applying binary search. How you will be applying binary search? If target lies in this range, is the middle position, mid position. Mid position can be anywhere from this index to this index if we are in currently non-rotated part. So if the target lies between this range and it, then you what you will do is, since it is not equal to the mid position, if it was equal to the mid position, we would have returned mid position itself. Now if the target lies in this range, and then you will do is, if mid position is not equal to, if the number at mid position is not equal to target, equal to target, then what you will do is, if you are in non-rotated part and if you are in NR part, and and target's value lies in range, which range? This range. So if target value lies in this range and mid position is not equal to the target and we are in the non-rotated part, then what you will do is, you will move your search space to a greater number. What you will do is, you will move left to mid position plus 1, or else you will move your right to mid position minus 1. Right, let me quickly erase the board. Then you will move your left to mid position plus 1 if that's the target is lying in this range. As if it's not the case, you will move your right pointer to mid position minus 1. What will be that condition? if the number at this right index is smaller than the target. So target is not lying in this range. Target is, let's say, situated. Let me quickly clear it. This was mid position and this was the right. Now let's say target value is situated here. Then you will move to this rotated part. Since it is also smaller than target, if it happens to be smaller than target, then you will move to the rotated part. So I hope the logic is clear to you. It will be more clear to you in the coding part. Now let's quickly dive into the coding part. Now let me quickly zoom out so that you will be able to see a larger portion of the code. Yeah. Uh, this is the search space. The search space in binary search, which is nothing but the indices of the array. Give- So this is a standard binary search with some tweaks that we have discussed. Uh, we are generating a middle position in the range, generating a middle position in the search space, middle or say middle value or say position in the search space. Search space is this initially, left is pointing to 0 and right is pointing to the last index of the array. So if we hit the, if the middle position, if the number at the array is equal to target, then we will simply return the mid position. Else if it is not the case and we are in rotated part, we will be checking if we are in rotated part, if middle position number happens to be greater than right. For example, if your mid position is pointing to this, let's call this mid position. Now if it's pointing to this, you will check what is the value at the right, the index at the right pointer. So if this value is greater than this value, then you are in the rotated part. So if you are in the rotated part and your target lies between middle position and left, if your target lies between this left included and middle position excluded, since if it were equal to middle position, number at middle position, then you would have returned that. If your target lies in this range, then what you will do is you will shift, uh, you will decrease your range by moving your right pointer to this pointer to one position ahead of this mid position, which will be, then what you will do is you will move right to mid position -1. Or if it's not the case, even your mid position is lesser than the target. So the number at mid position is lesser than the target, then you will move your left pointer to the position one ahead of the middle position. You will move left is equal to mid position plus one. And similarly, you will perform the operations for the rotated part. If we are in rotated part, then you will check for the range in which the uh, target would be lying. For example, if let's say your middle position was this, and if the number at middle position is not equal to the target, and your target is in this range, mid position excluded, to right is this, then what you will do, you will increase your left mid position plus one. Since mid position was lesser, then you will increase your right to mid position plus left to mid position plus one. Or if it's not the case, your number at the right position or the right pointer is lesser than the target. Let's say the target was 5, and since nums of right presently is lesser than 5, so what you will do is you will move to the non-rotated part, sorry. And how you will be moving to the rotated part, you will just shift right pointer to one position before this mid position, which is mid position minus 1. So this is how you will be applying binary search over two parts, since these parts are in sorted order. If the number at middle position is not equal to the target, if the number at mid position is not equal to target, then we will check for the two different parts of array individually. Pardon me if some spelling is incorrect. I hope it does not affect your learning. So this is how we'll be approaching the problem, and if you are still not able to find the index in this binary set, then you will return -1. So this is rest of the solution of the problem. If you still have any doubts, feel free to ask them in the comment section. So thanks for watching. Thank you.